All right, let's get started. Welcome everybody to the Python Bootcamp. It is officially the end of your summer, I'm sorry to tell you, but it is also officially the beginning of your love of Python, we hope. So what are the objectives of this bootcamp? Obviously, introduce you to the Python computing language, and most importantly out of everything, we want to get you writing Python code. And we want you writing Python code in such a way that you know how to do it just with your fingers without really having to think about it. Going from not knowing any Python to that obviously means you've got to do a lot of typing. We also hope throughout all of this to convince you of the utility of using Python in your own daily lives, in your own research, perhaps even in your own personal lives. And part of that is getting you going on what we call good coding practices or software carpentry, making sure you know how to do versioning the way that Python people do it, and also start teaching you about different curation practices for your code and for your data. We love Python, and so it's going to be very hard for us not to proselytize and bash all the other codes out there and all the other languages. We're going to try not to, because everybody and every language is very interesting and good in its own right, but sometimes it's going to be pretty hard to resist. Okay, so how are we organizing this? Well, as you know, it's going to be 3 days of intensive lecturing and coding. We'll be showing you demos in class. And the Python, if you go to pythonbootcamp.info and replace lectures with agenda, you'll see basically the whole schedule of the entire bootcamp. And we've started populating, at least the first day, with PDFs and other data files that you'll wind up needing. If you're not on Wi-Fi, you should do that. Try to get yourself on Wi-Fi now. We'll have breakout coding sessions. Essentially, we'll give you little mini assignments, and we'll ask you to solve a specific problem related to the last lecture that you saw. And there are a number of different counselors in the room who will be also manning the IRC channel called PyBoot, and you can ask questions there. You could raise your hand. We hope that as you start coding, you don't just get stuck, but you actually ask for some help. We're providing lunch and caffeine. That'll be outside. We are not allowed to have food and drink inside this room. And at the end of both today and tomorrow, you will get fairly large homework problems that you'll have to go home, and after you're totally sick and tired of Python, you'll be doing even more of it at home. You won't be graded on it, so it's okay. And perhaps the song that I played before we got going should have introduced you to this idea that this is not going to be a cakewalk. This is not just going to wash over you like I'm watching Khan Academy, website videos, and now I know Python. You're going to have to code. I'm glad all of you brought your laptops. And the more you code and the more you ask questions, I think the better and more proficient and more comfortable you're going to wind up being with Python in the end. Okay, so we all have name tags, the counselors, and if you need to contact us, you can get on Wi-Fi and go to this IRC channel. You can get to the IRC channel through the main website of the course. For those that don't have AirBears natively, because you're not a UCB affiliate, perhaps you're at LBL, we have a number of these different tags around in the wild. There's some up there, and there's some down here. Grab it sooner rather than later. Perhaps even just raise your hand now, and we'll have some of the counselors come down and hand them to you. The other thing is, if you want to tweet what an awesome time you're having or what a miserable time you're having, this is the hashtag for the bootcamp. You can communicate that way or do whatever you want to do on Twitter. Okay, so there's a couple things that you should know about us who are going to be teaching you over the next 3 days. Some of us are core contributors to some of the main Python packages that you'll be using. In particular, IPython and Matplotlib are two very important code bases that are related to Python, and we'll be teaching from those and using those heavily. But many of us are essentially just users of Python, and we've been users of Python for a very long time. I'm not a CS person, I'm not a CS major, but I think what's sort of a remarkable testament to the Python computing language is that somebody who really doesn't have a deep background in CS can feel comfortable enough teaching you an entire language. That's something that's really wonderful about Python. The other thing that's wonderful about Python is that you will inevitably ask me a question that I will have no answer to. But Python itself is usually a good starting point to get at that answer. If you ask me a question about history, we'll go look at Wikipedia. But if you ask me a question about syntax, how do you do this, how do you do that, what happens if you do X, Y, or Z, we'll just try it, and then we'll see. And so there's this natural sort of learning cycle within Python that really demands, if you ask a question, to go and try to answer that yourself. Okay, so let's get into it. What is Python? Why are we using Python? And then we'll get going with Python. Let me read this long blurb about what Python is. This is a sort of the most succinct way of describing Python and all of its sort of rich features. Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Its high-level, built-in data structures combined with dynamic typing and dynamic binding make it very attractive for rapid application development, as well as for the use as a scripting or glue language to connect existing components together. Python's simple, easy-to-learn syntax emphasizes readability and therefore reduces the cost of program maintenance. Python supports modules and packages, which encourages program modularity and code reuse. The Python interpreter and the extensive standard library are available in source or binary form without charge for all major platforms and can be freely distributed. Okay, what does that mean? Here's a couple of buzzwords that we rip out of that. Interpreted. That means that there is no need for compiling. If you're used to C, you have to write your code, you have to compile it, and then you execute it. There is no sort of compile stage. It's sort of done just in time. It can be object-oriented, which is a programming paradigm that uses sort of complex data objects or complex data structures, and each one of those data structures has knowledge of how to operate on itself. We'll see a lot of object-oriented programming tomorrow. Today, we're basically not going to touch on that. It's high level in that it abstracts from you a lot of the things that you normally have to think about if you're doing what might be called low-level programming. You're almost never going to be thinking about what's happening at the memory level. Python sort of abstracts that from you. You're not really thinking about putting different variables into different registers. You are thinking abstractly, and because of that, it allows you to write code, and the semantics and syntax of Python is very, very readable. It's one of the things that people who work on Python and people who invented Python are very proud of in the language, is that you can look at Python code and you can just see what it's doing. Dynamic semantics. This is a bit of a tricky one, and not everybody likes this or is comfortable with it. The idea here is that you can change the meaning of something on the fly while you're actually running it. I can set a variable equal to 1, an int, and then on the next line I can say that same variable is equal to some string. And that bothers a lot of people, and that's okay. This is weakly typed or dynamically typed. The nice thing about having a compiled language is that you can say and declare that I'm going to use a variable, it's going to be called A, and it's going to be of type long. And if you use it or misuse it, eventually the compiler will find it and say, you misused this, and it will either give you a warning or an error. That doesn't happen with Python. Built-in, it's got a very rich and very large core language. It also has many, many external packages that people are writing on top of it. Data structures, script/glue. The idea that you can use Python as a scripting language, a little bit like Perl, for instance, where you can more or less go line by line. It's not compiled, and you can, within an interpreter, actually inspect what's happening line by line. This is something you can't be doing in C or C++. We think of Python as a glue in a sense that it's got this beautiful sort of native language, but it also knows how to play very well with all the other things that are out there in the wild, like advanced visualization or large databases, or if you want to do parallel computing. Sort of Python has nice hooks into that. So you can, in some sense, prototype your code in Python, and then when you're ready, sort of interact with something large that's external to Python. There's almost always some native connection to that. Typing, it's just sort of the type of variable we have, and there's lots of different types. We'll see a bunch of those today. Syntax is the grammar which defines the language. Library is a reusable collection of code. And binary means that you can actually turn your Python script into an executable which can be run across many different platforms. So that's very nice. You're not sort of baked into just using the OS that you developed on. You can now sort of port it very easily and trivially over to other platforms. By the way, stop me if you have any questions. I'm happy to slow down here. Okay, so development history. It's a modern language. It's not been around all that long. Started in 1989 by this person named Guido van Rossum, who is now working for Google. It was developed in and became fairly mature in the 1990s, and it is not named after snakes. It is named after Monty Python's Flying Circus. So you'll be seeing a lot of that. Whether you like Monty Python or not, I don't know, but I'm sorry, you're going to have to deal with that. It's the cleanest humor that we're allowed to show in public, right? It still pushes a little bit of the boundaries. He is called the Benevolent Dictator for Life, or BDFL. He is still heavily involved in Python, but not really on a daily basis. He is sort of lording over the listservs as people are discussing new possibilities of add-ons to the Python language. This language is still evolving, right? It is not a dead language. It is still going. People are still pulling in best practices from other languages and trying to sort of incorporate it into the Pythonic way of doing things. And he really sort of still says, I think this is the way we should go. Or when there's two warring factions and one group says this is how we're going to do it, the other group says that, he says, come on guys, let's all get together and be friends. And he calls them over for a beer and they figure it out. So he still makes Python happen. But it is open source, and really from the beginning it was open source, and it has all the great things that come from being an open source large code base, in that it was well managed. And so version control is very good, code review is very good, but it has a huge group of people contributing both to the core language itself and then to the sort of ecosystem of third-party apps outside of that. It does rely on large amounts of community input, in particular for squashing bugs, for submitting patches, and for adding these third parties. Version 2.0 was in 2000. That was a major achievement. And we are using 2.7.3 in this class. It's okay if you're pretty close to this. We asked all of you to try to install the nthought distribution of Python, which includes an interpreter, which is version 2.7.3. And again, because the language is changing, the interpreter needs to sort of be able to keep up with the language. But if you're at, say, 2.6, it's probably not too bad. If you're at 2.5, that's not so good. If you're at Python 3 or something, that's also not going to be so good for this class. There was a major thing that happened. Basically, in 2008, there was an entirely sort of rewrite of Python. That was called Python 3.x, so now it's at, I think, 3.3. And it is not backward compatible with codes that you might write in Python language 1 point whatever, 2 point whatever. So that's the bad news. The good news, though, is that if you are developing in 2.7, as we'll be teaching to here, your code is fairly easily migrated to 3. There are essentially scripting tools which take your code and say, this is how I need to morph it so that it works in 3. The major problem with Python 3 for the moment, and again, this is a bit of sort of changing landscape, is that the major plotting package which most people use who are using Python, called matplotlib, is not yet ready for Python 3. Many of the numerical packages actually are, but until the plotting package really sort of makes the jump and becomes compatible, I'm not very comfortable teaching you Python 3. However, most of the changes from the end user perspective, and especially not the sort of power user perspective, are very small and very subtle. And so if you're in 2.7, one day when you get an email from us that says, okay, we think that it's time to go to 3, you can really just sort of press buttons and you should be okay. Okay, so why Python? Well, what are some of the alternatives? There's the sort of landscape of C, C++, and Fortran. These are wonderful because they have great performance, as you know. They have a huge backbone of legacy code that have been tested and tried over decades and decades. And they are compiled languages. The syntax is not obviously optimized if any of you are proficient in this language. You still know what a pain it is just to even get going. You don't have an interactive facility, so you essentially have to compile it, run it, see what happens. If you want to test stuff out, you want to prototype stuff out, you actually still have to go through the full compiling stage. Visualization's not really baked in, text processing is a little bit hard, et cetera, et cetera. Then there's the sort of Mathematica should be, Maple, MATLAB, IDL. It's interactive, so that's really nice. It sort of behaves a little bit like Python. You can just bring up a prompt and start typing stuff and see what happens. Wonderful visuals, extensive libraries. The problem is, I think in my mind, it's very costly. And it may not cost you much because many of you are students and you say, oh, I've got this free license. But then you realize you've just spent X number of years learning how to program in MATLAB, and then you get out into the wild and you're like, oh, now it costs me thousands of dollars a license. And now I want to run like a parallel code and I want to have 50 licenses going. You're like, I should have taken the Python Bootcamp. But you are all doing that, so that's okay. Proprietary. So if you really, really care about what the output of your code is, you're making some calculation of how some orbiter is going to land on Mars or not. You want to make sure it's using the right units. You want to make sure it's using the most up-to-date and whatever. You need to be able to get into that code. You need to be able to look at it line by line and inspect it. One of the nice things about Python and all of the third-party apps that wrap around it is that if you really care about it, it is no longer a black box. I sort of hinted at this in the context of parallelism. It is pretty unpleasant to use for large-scale programs. And then Perl, another scripting language, another glue, not so great with sort of computational and numerical computing as Python. If you want to see sort of a head-to-head comparison, you can go to this website. Again, all of these slides are up on the Python Bootcamp website. If you want to follow along, that's great. You're more than welcome just to see what's up here. But instead of having to write all this stuff down, I think you can just click within the PDF. Some more things about Python. I've said this already. It's free, highly portable, interactive, extremely readable, and some sort of cute way of saying this is it's executable pseudocode. For those that have taken a CS class or have thought a little bit about programming beyond just a few lines, you know that a very nice way of getting going is to sort of write out how you want your code to behave without getting into the nitty-gritty syntax of how it's actually going to be implemented. You say, loop over this variable, do this to it, plot that up, save it. You've just essentially written what looks like Python, right? In C, obviously, that's a ridiculous statement. Simple, in that non-professional programmers, we think, can use it very effectively. It has wonderful documentation and really great ways of sort of drilling down and asking questions of the documentation very easily. Google and Bing are actually very good for this. You can just say Python, do this, or you get an error message, you say this, and you usually get a pretty good answer to that. And it is really totally abstracted from you having to think about memory management. It cleans up your mistakes when you have an open file and your code just breaks. It'll actually close that file gracefully. It does what a programming language should do. It has a nice object-oriented model. For those that know about object-oriented programming, we're going to try to get you into that mindset tomorrow, and then on the last day, you'll be using it more and more. But it's not mandatory that you behave and interact with Python in an object-oriented way. Rich built-in types, very comprehensive. And interestingly, it has some really nice standard libraries akin to what IDL and MATLAB have. The concept of arrays for very fast iterations over large matrices, for instance. And nicely, and this I think in some sense mitigates some of the concern that people have with using Python when they want to run some old legacy code, is that there's just a very nice, elegant way to wrap around legacy code and actually reuse it. And so we won't see so much of that in this boot camp, but it's really the next step you go after learning this language. Okay, I know that I sound like I'm just trying to sell you something, but if you're not bought in now, then we've got a real problem. So it's amazingly scalable in that you can start off with just typing Python at the command line prompt and then start typing stuff and see what happens. And then you can get to the point of writing, a couple of different files, which then you could execute. And what you'll wind up seeing is that this is how many of the sort of programming paradigms now work. You start off prototyping a small idea, it gets bigger and bigger, and usually what you have to do is once you get to the production level, you generally have to throw everything out. You hire a bunch of people who've just graduated from a good CS program. You have them rewrite everything from scratch. In general, what you wind up seeing is that as your Python code gets bigger and bigger and bigger, it really doesn't become unwieldy. If you sort of adapt good coding practices from the beginning, you wind up seeing that it grows organically and that it can actually scale fairly amazingly. It's got everything, really. If you need to do something, like I need to send an email, I need to scrape some website, I need to interact with a supercomputer, you name it. I need to turn on some light somewhere. It just can do that, right? It's not necessarily in the built-in language, but there are almost always third-party apps for that. And the good thing is, as you're doing your prototype of, say, a new algorithm, and you say, boy, this works, but boy, it's incredibly slow, right? Because that is one of the net negatives of having a scripting language, is that's basically compiled just in time. As you get to the next line, it's saying, okay, now what do I need to do? But there are ways to sort of use the Python syntax and start sort of throwing in some of the nice aspects of C or Fortran. Some of that's already done for you. So in the numerical packages, most of them are all written in C or C++. And so when you're interacting with it at the interpreter level or the script level, you can just sort of rest assured that it's doing just about as fast as it could, as if you were executing that within C. Not all of it behaves that way, but if you really needed to do it that way, you can actually get into some of the internals and make it faster yourself. We won't have a large amount of time to talk about that. We'll touch on that, I think, in the last day. Python is very popular. It still wins awards, even in 2011. I've never heard of the Linux Journal, but I'm sure it's reputable. And I think it's important for you to recognize that Python is used a lot in Berkeley. Some of the core development actually is happening in Berkeley. But I use it basically throughout my entire workflow. Every single day, I'm doing something with Python. My group uses it for running a robotic telescope. We interface with legacy hardware device drivers that were written in C in the late 80s. We talk over serial and parallel lines to an old telescope built 30 years ago. We oversee all the functioning subsystems themselves written in Python, sending emails and pager alerts when the telescope is distressed. We move images around over the network using Python. We interact with databases. We reduce data in Python. Sort of everything that we do with this telescope project is basically got Python built in. And it's the largest robotic telescope in the world that is essentially autonomous and more or less following up events in the sky without any humans in the loop. We use it for data reduction, so astronomers in the room will know about FITS images and the FITS files. We can easily parse through those. We wrap around third-party software as the glue. I use it as a calculator all the time, prototyping new algorithms, making plots for papers. That was the hardest thing for me to give up. I came from a C and IDL background, I have to admit. And then at some point I just said, no more. I'm done with that. And the first time you have to make a plot in Python for a paper that you know is going to be published somewhere, it's a little bit painful. but you do it a few times, and then you figure out how to do it. So you can make just as pretty plots in Python as you can pretty much in any other language. And we use Python all the time to make fast, parallel, and efficient web services. Google has a hosted Python service where you can build websites that actually can do stuff. We use it for research and collaboration. We had an undergraduate who didn't know much Python before the summer, basically ramp up a whole website that allowed us to do asynchronous conversations with people across the world. We use it for a crowdsourcing platform that was written entirely in Python. And the other important point, I think, out of all this, which hopefully gives you some level of comfort, is that many of the companies, well, all the companies that you see here and many of the ones that you don't are using Python in some way. The app that we used to check you in this morning was written in Python. Google uses Python basically for all of its internals, Quora, you name it, right? Everybody is using Python, even the Large Synoptic Survey Telescope, a $1 billion new facility which is coming online in a few years from now. All of their analysis tools are being written in Python. And even your grandmother uses Python. So if you don't use Python, your grandmother uses Python. We have a number of different ways to work with Python. There's an old sort of legacy way called Sage, which gives you nice sort of inline access to plotting packages. But the sort of new emerging de facto use of this so-called notebook paradigm is the IPython notebook. And all of you already had that if you've installed the nthought distribution. Basically, you can be running Python code, and inline you get some nice plots. And the nice thing is you can then send those off to your friends and collaborators, and even use curation practices and versioning to make sure that you've got the sort of good snapshots of your code. Matplotlib is our sort of major code base for doing plotting, nice visualization of images, obviously histogramming, time series data, you name it. If you need sort of 3D visualization, there's something called Mayavi, and we'll see some of that, I believe, on the last day of the bootcamp. This is basically the sky's the limit for being able to visualize whatever sort of complex data you have. And now what's pretty wonderful about IPython is that it gives us pretty easy access to parallelism. So if you've got a code that very naturally parallelizes with just a few lines, you can basically say, do this all in parallel. And you'll see an example on the last day where we're going to spin up an Amazon cluster, and we're going to do a very large computational project before your eyes using IPython. Animation, obviously, all the stuff you'd want to do as physical scientists to visualize whatever is happening with your numerical integrations. So let's get started tackling Python. Does anyone know where this is from? Snakes on a Plane, okay. Does anyone know what the prequel of Snakes on a Plane was, written by Monty Python?
Frogs on a boat.
All right. So as I've said this before, this is not for me. This is for you. So please speak up, raise your hand during the presentations, after the presentations. There are a number of counselors around you who are more than happy to just jump over. If I can't answer a question right then, we'll be able to figure it out offline. Join the IRC channel. You can get to it through the website of the class. Send an email to us, and I think some people, some of the counselors are manning that. And then there's the Twitter hashtag, and you can get on that. Don't say, like, how do I do this on Twitter, or you can, but it seems silly. All right, let's get going. So if you are in Mac, which looks like roughly 60% of you are, from the command line, type Python, and you should see something that looks roughly like this. You can then type 2 + 2. And hopefully you'll get out 4. If you get 5, let us know. You need a new Mac. Likewise, if you're in a sort of Linux environment and you're running X11, or if you're within an X term, same exact thing. Fire up Python, type 2 plus 2, you get 4. And likewise, if you're in a Windows environment, you have to get yourself a terminal window. You can type CMD from the executor programs window, and you should be able to get this. Wait a second. Has everyone fired up their Python interpreter? Yes. Okay, good. Now, I'll just basically just show you the Mac way of doing this, but I think it's the same across all the different platforms. So you've typed 2 plus 2, and you're going to basically hopefully get 4 out of that, and it returns you back to another Python prompt. Okay? So now you can do something else in there, but say that you want to exit out of that, you could type exit and then parentheses, open parentheses, close parentheses. So try that. Or you can type Control D, and that should get you out as well. So if I do Control D, it just dumped me right back to my command line. If I type Python again, and then I can type 2 plus 2 or whatever I want, or exit, and I wind up getting back to the command line. Everyone knows how to get into Python now and get out of Python. Okay. There is another Python out there, and this is an executable. I should say something about what is Python when you type it at the command line. That's an executable. And that is something that is interpreting Python code, and it's doing something with it. You can think of it sort of as a just-in-time compiler if you'd like, but there are different implementations of executables that know how to faithfully execute the commands, either at a command line or a script, that conform to Python as it was handed down for 2.7.3. So if I have a very old version of a Python executable, and I have a script that's new and uses some of the new paradigms from the current incarnation of Python, it won't work. So when we say type IPython, we're not really doing anything with the language. We're just basically starting up some code base that knows how to interpret what I'm about to write. And this IPython gives me an interactive Python, which looks a lot like what we just did when I just typed Python. Except you notice it sort of marks things up in nice colors here. And it is really the interpreter that we use in our daily lives. So you feel free to use Python, but most people will wind up using IPython, which is just sort of a nicer marked up version that has special things about it that you'll see more and more of throughout the bootcamp. All right, we're fired up. We know Python now. 90% of it's done. You know how to fire up the interpreter. That's actually very facetious. But it's actually not so untrue in the sense that what you'll wind up seeing pretty soon is that when we don't know how to do something in Python, the interpreter, especially IPython, is going to be our friend. It's going to allow us to drill down into the documentation, to ask questions, and actually inspect our data in very nice ways. Okay, so we actually have to start writing some Python code for this to be anything but a trivial exercise. Here's what some Python looks like. It's been marked up and I guess colored very nicely by what I use to do my Python development, a text editor called TextMate. If you're a UCB employee or student, you can get TextMate for free. You can actually all download it now, install it, and I think you get a 30-day free license or something. But if you want to always have it, you can go here, and that's the link that takes you to the license files. You log in with your Cal credentials, and you get the license file. These files usually end with a .py, and so when you see a .py somewhere in a directory structure, you can be fairly assured that it's going to be a Python script. We'll wind up calling these modules later on. Feel free to use whatever editor you want, but you better start thinking about which editor you're going to use. Some of the ones that do this colorization for you, like BBEdit, Text Wrangler, Notepad++, etc., are all very, very good and really help you with getting Python syntax right. And some of the older editors, of course, are still very useful, very powerful. Feel free to use whatever editor you want. We're completely agnostic to that in the bootcamp. The other thing about Python, and IPython in particular, is that we can fire up this notebook, which basically starts a server that's serving out a Python interpreter. And if you type this at your command line, IPython notebook, if you have the nthought distribution installed, or a fairly new version of IPython, this should just work for you, and it should start up a browser. And you should see, you should see two different tabs that are open. One tab that's open, sort of an intro tab, and then if you click on Make New Notebook, it'll take you to this tab here. This looks a lot like the IPython interpreter because it basically is, but you can interact with this server, even though this is in sort of a terminal window. You can do this within a browser window. Okay? Any questions? Yes.
What's the interface that you use to code usually?
What's the interface that I what?
That you use to code, you use IPython or just from the terminal?
Me personally. So I use IPython and not Python as my sort of de facto interpreter. And the IPython notebook, which was started by, and IPython, the whole project was started by one of our former counselors who's still at Berkeley but couldn't be here this week, Fernando Perez. They're ramping up very quickly with this, and what you'll wind up seeing is the IPython notebook is very, very powerful. It's not fully there. It doesn't have all the functionality of IPython or the Python interpreter. And in particular, when people need to interact with the interpreter, it's not quite there yet. But I think within the next 6 months, if I was teaching this boot camp, we would basically do it all from within the notebook. So you'll be seeing more and more of the notebook over the next 3 days. But there's really lots of different ways you have to just be comfortable with it. I should say, if you don't like Monty Python and memes, you're going to have a very bad time. I spelled Monty Python. That should be with a Y at the end. So I apologize. Caffeine and adrenaline only get us so far. We have to try to make you guys laugh. Okay, so that's it for the sort of intro lecture. If there aren't any other questions, I thought I would just jump into the first substantive lecture. Your laptops. And the more you code and the more you ask questions, I think the better and more proficient and more comfortable you're going to wind up being with Python in the end. Okay, so we all have name tags, counselors, and if you need to contact us, you can get on Wi-Fi and go to this IRC channel. You can get to the IRC channel through the main website of the course. For those that don't have AirBears natively, because you're not a UCB affiliate, perhaps you're at LBL, we have a number of these different tags around in the wild. There's some up there, and there's some down here. Grab it sooner rather than later. Perhaps even just raise your hand now, and we'll have some of the counselors come down and hand them to you. The other thing is, if you want to tweet what an awesome time you're having or what a miserable time you're having, this is the hashtag for the boot camp. You can communicate that way or do whatever you want to do on Twitter. Okay, so mini assignments, and we'll ask you to solve a specific problem related to the last lecture that you saw. And there are a number of different counselors in the room who will be also who will be manning the IRC channel called PyBoot, and you can ask questions there. You could raise your hand. We hope that as you start coding, you don't just get stuck, but you actually ask for some help. We're providing lunch and caffeine. That'll be outside. We are not allowed to have food and drink inside this room. And at the end of both today and tomorrow, you will get fairly large homework problems that you'll have to go home, and after you're totally sick and tired of Python, you'll be doing even more of it at home. You won't be graded on it, so it's okay. And perhaps the song that I played before we got going should have introduced you to this idea that this is not going to be a cakewalk. This is not just going to wash over you like I'm watching Khan Academy, website videos, and now I know Python. You're going to have to code. I'm glad all of you brought it. There's a couple things that you should know about us who are going to be teaching you over the next 3 days. Some of us are core contributors to some of the main Python packages that you'll be using. In particular, IPython and Matplotlib are two very important code bases that are related to Python, and we'll be teaching from those and using those heavily. But many of us are essentially just users of Python, and we've been users of Python for a very long time. I'm not a CS person, I'm not a CS major, but I think what's sort of a remarkable testament to the Python computing language is that somebody who really doesn't have a deep background in CS can feel comfortable enough teaching you an entire language. That's something that's really wonderful about Python. The other thing that's wonderful about Python is that you will inevitably ask me a question that I will have no answer to. But Python itself is usually a good starting point to get at that answer. If you ask me a question about history, we'll go look at Wikipedia. But if you ask me a question about syntax, how do you do this, how do you do that, how people do it, and also start teaching you about different curation practices for your code and for your data. We love Python, and so it's going to be very hard for us not to proselytize and bash all the other codes out there and all the other languages. We're going to try not to, because everybody and every language is very interesting and good in its own right, but sometimes it's going to be pretty hard to resist. Okay, so how are we organizing this? Well, as you know, it's going to be 3 days of intensive lecturing and coding. We'll be showing you demos in class. And the Python, if you go to pythonbootcamp.info and replace lectures with agenda, you'll see basically the whole schedule of the entire bootcamp. And we've started populating, at least the first day, with PDFs and other data files that you'll wind up needing. If you're not on Wi-Fi, you should do that. Try to get yourself on Wi-Fi now. We'll have breakout coding sessions. Essentially, we'll give you a little... All right, let's get started. Welcome, everybody, to the Python Bootcamp. It is officially the end of your summer, I'm sorry to tell you. But it is also officially the beginning of your love of Python, we hope. So what are the objectives of this bootcamp? Obviously, introduce you to the Python computing language. And most importantly, out of everything, we want to get you writing Python code. And we want you writing Python code in such a way that you know how to do it just with your fingers without really having to think about it. Going from not knowing any Python to that obviously means you've got to do a lot of typing. We also hope throughout all of this to convince you of the utility of using Python in your own daily lives, in your own research, perhaps even in your own personal lives. And part of that is getting you going on what we call good coding practices or software carpentry, making sure you know how to do versioning the way that Python